This is build up your understanding question 4 from the topic thermal physics from the book Pathfinder. So let us see, it's a very good question. There is a special container having tilted bottom. So there is a tilted bottom. It has a uniform slope. So slope, it is a straight line. It has one inlet A at the top. So this is the inlet, and one outlet at the lowest position. So this is outlet, this is inlet near the bottom. Now it contains large amount of ice at 0°, which you can see. From the inlet, the water of temperature theta I equal to 28 degree is continuously fed to the container at this rate, Ri. So from here, continuously water is coming. Now space between the pieces of ice permit water to run down and come out from the outlet. So what happens now, because there is some space between the ice, so water will run down, and then this is how it will flow and come out. The outlet is made wider, so from the inlet, to prevent accumulation of water in the container, so that there is a continuous flow. Now, inner surface is adiabatic, so there is this cannot get heat from the surrounding. Specific heat of water is given, L is given, latent heat is given. Then we have to find out weight of water coming out from the outlet if its temperature is 1. So key point is temperature of inlet is this, or water is coming at this temperature, going at this temperature. Inside there is ice has temperature 0, right? So let us see how do we solve. So this kind of questions, always you have to start thinking in blocks, right? Step by step. So first let us consider inlet, and let us consider only inlet, forget about outlet, right? So if we consider only inlet, then what is happening in 1 second? Ri gram of water is entering at theta. Theta is 28 degree. And it converts, let us say it enters and converts to 0° water, right? So I'm assuming, suppose this happens. Then how much heat will be rejected? Ms delta T. So M specific heat, and this is delta theta, temperature, theta I minus theta. Theta here is 0. So theta, yeah, this is theta equal to 0. So this is basically 0. Now, so this is now what do you have inside? You have Ri amount of water additionally, right? And originally whatever amount of ice was there, that is there. So you have Ri amount of water plus original amount of ice plus this much amount of heat, right? So what happens? What converts to what? That we will see later. Now the same thing we do for outlet. Now we forget about inlet. Now this is the outlet. Let us say Y amount of water leaves the outlet in 1 second. Then amount of heat needed will be how much? This is here right now temperature is 0°. So if it is leaving at 1 degree, how much heat is needed? Again Ms delta T. So this is why this is the rate in 1 second. This is actually 1 second. I have not written. So y SI theta naught minus theta, right? Theta naught is 1 and here it is 0. So this much amount of heat it is taken. This much amount of heat is available, right? Because the water converts to ice. And this water is moving, is going at 1 degree. So this has taken this one. So what is the net heat you have? Heat balance. This minus this, right? So this minus this is the net heat available in the container, right? This is equal to what? Now this heat will be utilized to melt the ice, which will be equal to L m dot into L. So everything is in 1 second. So that is why this is rate. Now m dot is the amount of ice converts to water in 1 second. Fine. And what else? This is one equation. Another equation is mass balance. Ri amount enters and Y amount leaves. In everything is in 1 second. And m dot amount converts from ice to water. So if we convert, if we do mass balance, then Ri is the amount which is entering, m dot is the converting, and Y is the amount which is leaving, right? So entering plus this much is added, this much is leaving. So if you solve these two, just eliminate m dot from here, you will get this as the answer, right? So it's a very good question. Again, the same question can come in JEE Advanced also. So thank you for watching. If you like this video, please like this analysis, please give a like to this video, and please subscribe to this channel also. Thank you. Thanks a lot for watching. Wish you all the best. We'll meet in next video.